Hello, good evening, everybody, and welcome to the 22nd Hangout of Startup Portugal. So November has brought many news. So we were at the Web Summit where we launched several initiatives. We had the opportunity to have the Road to Web Summit pitch, where we had 3 winners. So we want to have you take a peek on ETIAC, Jupiter App and Active, who were the big winners of our Road to Web Summit 2023 edition. One of the highlights of this Web Summit was also the presentation of our startup and entrepreneurial ecosystem of 2023. So we also want to have you, if you are interested, you can keep an eye on this new report that we launched with several numbers and information about the ecosystem that can be useful for you and for your startup. We also publish each year the ranking for the universities in Portugal, and this year we were very proud to announce that Universidade do Porto was Portugal's best entrepreneurial university of 2023. So heads up to everyone in Porto. We're very proud of this. We also have great news for entrepreneurs looking for new ways of financing their startups. So the second tender of the vouchers for startups and vouchers for incubators and accelerators was launched during the Web Summit. The applications will be open from tomorrow on. So also, if you want to keep an eye on how you can apply to this financing, you can also check our website and our social media. We have a lot of information that you can read before you apply. So after this, we're going to dive in the topic that brought us here today. So today we're talking about deep learning. And for the conversation, we'll have Luís Espírito Santo from Deep Learning Sessions, to whom I want to ask for a big round of applause, if you may, please. He was a big partner in developing and organizing this session today, and very important for us. So, and we are very glad to have here Maria Guimarães from AIA, who is AI researcher at Neurospace, João Gante, from Hugging Face, Luís Charmento from Indutiva, and Guilherme Viveiros from Dot Moves. I think I said it right, I hope. So, as usual, we will start today with the warm-up pitches. And to present the pitches, I want to ask for my colleague, João. Okay?
Hi. Let's start today by welcoming Philippe from iKeeper to pitch us a very cool and... Come on. Don't be shy. Give the man a round of applause and let's hear all about iKeeper.
Onde é que eu posso passar depois à frente? Okay. 60% of all marriages end in divorce. 30% of students that enter university end up not finishing their course. And 55% of the people that you hire will end up resigning in less than 1 year. What does all of this have in common? People aren't finding their best matches. And that is precisely why me, Filipe Ferreira, the CEO at Keeper, we created the first matchmaking platform that will help you make your best decisions, whether it be in career, personal life, or even your relationships. As a matter of fact, we already found the perfect match of more than 1,500 people. We also have partnerships with universities that we help match students with teachers, students with courses, and even startups that enroll in their acceleration programs. We do not only help startups and universities, we also help companies. And we help them on their recruitment processes, we help them find their best candidates, we help them find their best matches for their team. And this also resulted in around 80% employee reduce in turnover. How does this work? It's very simple. With just 10 questions and our simple quiz, we onboard the user and are able to assess their personality type. By doing this, we can know correctly their best matches. And by the continuous use of our platform, our algorithm will keep learning with the user. And with the continuous usage, we will be able to give them their even better matches. By finding these perfect matches, and by centralizing this in only one platform, we are able to aggregate in just one platform all of your favorite activities, the restaurants that best match with you, job openings, students, everything, courses, etc. But we also have an API, so our partners can also integrate our API in their services, so they have the match on their side. If we take a simple look at just these three verticals, we already see 1 billion market cap. But with some also other proven use cases and thinking a little outside of the box, we also had some use cases in fitness by matching personal trainers with their customers, and by also matching VC funds with startups. How we make money, it's very simple. We just take a 10% fee on every service that we recommend, and on the case of team management and recruiting, we also take a fee per match. As a team, my name is Filipe Ferreira, and I am the CEO. I've been studying psychology and personality theory for more than 10 years. I also raised some previous money for other startups. And we also have Paulo Alves with some other successful exits, and Vitor Simões with more than 20 years in software development. So we have to make a great product. Currently, we are asking for 500,000, so we can reach our next milestone of 75,000 users and 500,000 in combined revenue. And we need your support. So that's what I am asking, because at Keeper, we don't only find the best matches, we also create connections that transform people's lives. Thank you.
Thank you, Flip. Well, to our Porto stage, Fahima Farahi, I hope I didn't butcher your name, to tell us all about wiseword.ai.
Hi, I'm Fahima, and I'm CEO and co-founder of WiseWord. So let me ask you a question. How much of your company's success is related to your employees' soft skills, like communication, work ethic, problem solving? Interestingly, 80% of companies' manager and 92% of talent pros believe that soft skills are crucial for company success. And by 2030, 2 out of 3 jobs would be soft skills intensive. However, only 3 out of 4, however, 3 out of 4 organizations report a workforce soft skills gap. So, where is this gap coming from? The gap is related to the current solutions in the market. The current solutions are mainly one-time solutions, like one-time workshop, one-time test, or one-time AR or VR sessions. On the other hand, MIT study reveals that companies that invest on long-term practice for soft skills can increase a return of their investment 250%. So our approach is different in the market. Our approach is Duolingo style. Daily practice, regular practice, gamified, interactive, and customized to each employee. Customer empathy in the sales team, and actually select the team, add the goal, and select the related skills, and add the employees. In the employee side, each day they have 3 challenges. These challenges are AI generated, that, as you can see, at the end of each challenge, AI asks the employee, how do you want to resolve this challenge? And employee have a conversation with AI that we semantically analyze which skills are they using to resolve the challenge. So AI gives them a score in terms of the skills that they have used, and immediate feedback and the result for their actually approach. So what's going on in this market? Soft skill market, the size will be 60.8 billion by 2031, and the dominant actually region is North America, followed by Europe, and the fastest growing market is Asia Pacific. And in terms of the market opportunity, TAM individuals interested in personal growth is $71 billion. Some individuals interested in soft skills is $60 billion, and some mid-sized tech-oriented companies, $152 million only in US. We have three types of players in the market. The first two that we consider them as our direct, actually, competitors, AR/VR assessment, that they are focused on workers and they are session-based. The second type is one-time tests that are mainly focused on hiring process. And the last players that we consider them as our partners are coaches and mentors. So our vision is turning our human skills to our superpower. And by making actually tailored assessment and regular assessment, we want to stick out in the market. Our business model is first B2B subscription per employee per month, and then followed by B2C premium. Our go-to-market plan, we have two approaches. First, direct selling through approaching HR managers, and then partnership with coaches and HR agencies. So we started the journey 6 months ago, and we teamed up, we did market research, product design, and we developed the product within 2 months. And we launched last month, and we onboarded 5 initial companies. And now we are raising our pre-seed round, 450K euros, to target 0.40% of our sum. We are 3 co-founders. I'm CEO, and I previously founded 2 businesses achieving international growth and sales, and previously published 3 neuroscience-related paper with Max Planck. And Sina, my CTO, has 2 prior scalable product development experience and applying 10-year art and design experience to product development. And our lead designer has more than 10 years experience in designing B2B gamification solutions and holding 200 B2B focused soft skills workshops. Thank you, and I want to invite you join our mission to improve soft skills and make it measurable, as AI is simplifying our hard skills day by day. Thank you.
Thank you so much, Fahima. And now back to Lisbon to invite Daniel Nunes, CEO and founder of Jungle AI. Come on, come on.
So hey everyone, just a quick note, I'm not CEO and founder. I'm just a machine learning engineer at Jungle. So today I will talk about Jungle and also focus a bit on the reasons why deep learning has been with Jungle since the beginning, basically, because we thought it would be interesting to have this given the Hangout topic. Jungle is a company that focuses mainly on providing solutions to predictive maintenance problems and also power forecasting problems. So when we think about machine performance and the ways to enhance this, let's think about things like wind turbines, solar panels, it's basically where we play at. You can think of this in 2 major ways. One is to provide new infrastructure, new technology, and the other is to provide ways of looking into this already existing infrastructure and be, I guess, smarter or more efficient in the way that you use it. The green energy space is one where we mostly act on because we think it's important and also because it's one that benefits from both sides of this spectrum. How do we work? So we basically work on the second part of this solution. So we provide our clients with software solutions to improve the efficiency of what they do with the already existing infrastructure. We call this Canopy. Canopy is our main software, which is basically a dashboard that we provide to our clients where they can, with little to no overhead, they just have to share the data that they already produce. Imagine an asset owner with a wind farm with 30 wind turbines. They provide the sensor data, and then they can, in real time, read this data in very user-friendly, but also really deep ways so that they can find interesting relationships, assess the state of what they are doing at a given moment. And then, and this is where deep learning comes into play, they can also look at the data in real time and compare that with a prediction of what should be happening at a given moment. This is far from a linear problem. It's quite a complex one because there's dozens of sensors on each asset, and each asset relates with the other assets in complex ways. But we can see very easily why this is important, because once you have information on what's going on and what should be going on, you can very early on assess how you should actually tackle the problem, actually before it becomes catastrophic, which would probably be the moment where you realize that something is happening. This obviously leads to a big reduction in costs, maintenance costs, because you can, once again, pinpoint exactly where to act. A big and tangible increase in production, because your asset now has a lot less time where it's not producing energy, or and all of this obviously leads to higher operational efficiency, because you basically have a lot more uptime than you have downtime compared to before Canopy. So why has deep learning been with us, and why is it at the core? Mostly it's because deep learning is excellent at prediction jobs. It can do it very well. It can deal with extremely complex data, and that is basically the core of why we do it. We need good solutions as the first place. But then we can enjoy these two other things, and we think this might maybe spark the conversation around deep learning. We can become model-centric, which is very interesting for us, because we can relieve some stress from the domain experts that we have and gather insights just from the model that we train. And also, we can deal with a lot more simplified data processes, because current state-of-the-art data pipelines and also architectures for deep learning models are very capable of dealing with problems that were very classic in machine learning, like missing data. We can deploy faster because we have to worry a lot less about missing data, for example. So yeah, thank you a lot. I'm Daniel, I'm from Jungle, and I work as a machine learning engineer there.
Thank you, Daniel. Sorry for my gaffe. I've just promoted you. So now let's welcome our panel discussion. First in Porto, Guilherme Viveiros from .moves, and then Luís Sarmento from Inductiva. A round of applause for them, please. Come on, join the stage, man. And now here in Lisbon, João Gante from Hugging Face, Marta Guimarães from Neurospace. Come on, come on. And our and Luís Espírito Santo from Deep Learning Sessions to moderate our panel.
Hello, can you hear me fine? Yeah? In Porto as well? Hello, Luís. Hello, Guilherme.
Okay.
Yes?
Hello. Yes.
Oh, nice. Okay, so we are set. So, yes, we decided to do this session. Actually, we didn't decide. It was a challenge made by Startup Portugal, and we decided to bring this topic here because, well, I'm one of the co-organizers of deep learning sessions, and we think it's very relevant, very recent in a sense. And I would like just to see how many of you have heard of deep learning, this word. Can you put your hands up? Okay. There are some people that never heard of it, so that's fascinating. But actually, how many of you could explain deep learning to a 5-year-old? Okay, we have one. So, 2, shy, 3, one, one confident and 2 shy. But basically, what we're going to do here is this. I'm going to start by, first of all, thanking you for being here, all the 4 of you. And I will start by asking to Luís, how would you explain deep learning to a 5-year-old?
Okay, so that's a tough question.
Yes.
I actually have a 5-year-old daughter that just turned 5 this weekend, but I've never tried to explain any of these things. I want to make sure that she grows up happy, so I never tried that. But because this was a challenge, right, to explaining to a 5-year-old, I was actually thinking about how could I do that with my daughter. So I brought some high-tech components. They're called post-its. I don't know if you ever heard about these, super high tech. So I decided to see if I could explain deep learning with post-its. And I was there waiting for this moment. So I was just playing with post-its. I think people thought that I was crazy, but I will start
Perfect.
with one post-it. So I just folded the post-it seats like a little harmonic, right? So if I have an input, right, on one side, let's say that this side is the input, then I can have an output. Let's say the input is something that is vertical, and I can have an output just by using this that is more or less vertical, right? I can do like a little bit to the left, a little bit to the right. So I have an object that maps whatever I have in one side to the other side, and I have some flexibility. So I can actually map a vertical input to a slightly bended output, right? I can do that. Now, the cool thing is that I can just join post-its. Post-its are great because they stick, right? So I can actually, now instead of having one, I have two post-its, right? And this is pretty cool because now I still have an input. So these are two post-its. One is green and then one is white. And I can still have a connection between the input and the output. But now I have a little bit more flexibility, right? So the input can be a little bit different and the output can be a little bit more tilted than the input. So I have a little bit more flexibility. Now I can keep going, right? So I can build longer chains. So now here's 4. Now things become really exciting because I can almost have something which is vertical on the input and totally horizontal on the output. Okay, and this is the notion that we have in deep learning. It's one of the notions that we have in deep learning. We can keep assembling these things, right, and create even more complex chains. So I can connect an input to an output in many different ways. And I can have inputs which are actually more complicated. I can have an input that is 2 sizes tall, and I can have an output which I know already that has to be a little bit horizontal. So it has to be something like this. And I can still connect these inputs to the outputs in very creative ways. So what deep learning does is something similar, so I'm trying to explain to a 5-year-old, right? Something similar to more complicated signals, more complicated pieces of information. So that's basically, this is deep learning, okay?
Yeah.
And there's one trick that I didn't explain is how you make sure that the input maps to the output. That's also part of deep learning. But the core idea behind deep learning is that you can play with these things and you can also push information back. So you can adapt the output to match the input in a way that is very flexible.
Yeah.
Well, does this work? Was this okay explanation?
Yeah, perfect.
Okay.
A round of applause. It was a great challenge. Does someone want to add anything to this great explanation?
No.
It's a great analogy.
Yeah,
Yeah.
I really liked it. Thank you very much, Luis. So I will go to another question that is, so this is like a very overall explanation, right? And I'm talking to you, Marta, now. So what most of the people actually learn deep learning by hearing these kind of analogies, which work really well to explain the basis, but bring a lot of misconceptions. What are some of the most common misconceptions in deep learnings?
Well, I'm still recovering from this explanation. This was too awesome and too cool. So I'll give my best. There are a lot of things that can be said about that. But I think I'll follow the hype and talk a little bit about ChatGPT, I guess. So probably everybody's waiting for this. So a lot of people believe that this model works just like our mind, and this is definitely not true. And there are also people that believe that every time they play with this model, with ChatGPT, there's some ginormous database at real time, and every time they ask something, this model goes to this spot and grabs this answer, and this is also not true at all. So based on this awesome explanation that Luis just gave, um, I'll try to explain, but imagine, so you have the post-its, so you have this harmonic, and this harmonic, I'll keep with post-its,
Yes.
it's cool, it's cooler. These post-its, they indeed use ginormous databases, but these databases are used to learn the depth. For example, Luis explained the difference between increasing these post-its. So these databases are used to define the structure, let's call it this way. And then it becomes almost like a static object. And this is what it is used in real time, let's say.
Okay.
So basically, and going back to ChatGPT, every time a person taps something or asks something, this model is already trained. And at the end of the day, what it's doing is simply looking at the sequence of words that you gave it to the model and predicting the probability of the next word. And this goes around word by word until you have a final text that is cool to you.
Yeah. Yeah, that's indeed one of the greatest misconceptions. I've heard a lot of people talking about how they don't understand how ChatGPT has a limit to their knowledge, you know? Like, if it's getting information, why doesn't it know, like, things from now on that are on the internet? That explains, basically, because it's already trained. Yeah, great. So, yeah, I will ask Guilherme now. So we talked about ChatGPT for text, but, well, deep learning is not just for text, right? And Guilherme knows that, and I would like to hear from you. What are the main applications of deep learning, and what could be a sign that a problem should be solved or can be solved using deep learning?
Yeah, so deep learning has been amazing. You have a lot of fields that you can use and with deep learning. In my opinion, to identify if a task can be solved with deep learning, you have to follow at least one of these criteria. The first is that the task that you're doing, you have a lot of data. The second is that you can try to learn a pattern from data to make decisions. And the third one is that you have an initial solution where you have the privilege to grow the data sets through time, and then you can refine and iterate your model. So, for instance, at Dotmoves, we are developing new algorithms and statistical models that can detect more than 50 fitness exercises for users, such as push-ups, squats, burpees, and much more. And we add to these models the ability to correct the posture of the users in real time. So, as you can imagine, this task is quite specific to our use case. So we don't have the privilege to have, like, I labeled a vast amount of data that is pre-labeled. So what we did is we try a different approach. We have an initial solution, and as the user interacts with our app, we grow our dataset size, and then we can refine our model and keep iterating the solution. So, yeah.
Yeah. Okay. So computer vision is another big area of application, such as text. Well, I have here João from Hugging Face that develops these kind of models for different domains. So besides, if you want to add something to what we have already said, you are always can add something. I would like to direct one question for you that you might be able to answer. That is, how does one start working with and using deep learning in a company, for example? Or, yeah.
That's a very good question. So the first thing I would try to assess is when not to use machine learning. Because when you have a powerful hammer, everything looks like a nail. So you need to be really careful when to use deep learning or not. As Guilherme said, data is the most important thing you can probably have in a machine learning problem. So you must be sure that you either have data or that you have a strong, powerful model as a baseline for your problem. There are many tasks where you don't have a model at all, or you have some form of approximation. But there are other tasks where you already have a strong baseline. For instance, if you have a text task, you already have a lot of pre-trained models that have been trained on the corpus of the entire internet, pretty much, and knows how to continue generating text given a certain input. So if your problem has a very common type of data, text, image, audio, video, etc., there is a strong likelihood that you can use one of these models as a starting point for your product, for your company, etc. However, if your data is an Excel spreadsheet, it really depends on the data inside your spreadsheet in terms of quality, in terms of quantity, in terms of whether there is some form of, I want to say correlation, but this is not the correct technical word, between the data and what you want to learn from the data. So I would say to A, first consider the type of problem you have at hand, B, whether you have data or not, and C, be mindful that not all problems can be solved with machine learning. It's a powerful tool, but we are still at the beginning of the transformation with deep learning.
So I think now it's time to answer one question, because you mentioned machine learning, and we're here talking about deep learning, right? So here comes the question: what is the main difference between deep learning and machine learning? And because people talk about it in the same way most of the times, and also what is the difference between deep learning and AI? Are they the same thing? And I will start with Luis, maybe. You get the hard questions.
Right? So I mean, there's a lot of discussion about this, right? But from my point of view, my personal point of view, deep learning is a subset of the field of machine learning that encompasses a lot of other methodologies, also some other methodologies that have been around for many years and are not as sophisticated, but are almost like the basic components of deep learning. But I think deep learning stands out a little bit from the general machine learning scene, I would say just because of its simplicity. It's a really simple idea that is just being applied at a scale which is enormous. And I think the way when I think about deep learning, I think about very simple methods applied at a huge scale, at enormous scale, and it's just a different mindset on how to think about problems. Is like, okay, let's have these very simple components and just chain them together, and then use tons and tons of data. So I would say that although it's a deep learning, in my perspective, is a subset of machine learning, I would say that there is a difference in the mindset of people who have been doing machine learning for many years and people that are doing deep learning now. I think the mindset changes. AI, well, it's really not a good term, because it implies defining what is intelligence, and that's really difficult. But it's just a big bag where we put a number of things that we can consider just sophisticated computing that does things that we humans also do more or less.
They try to mimic human intelligence.
In a certain way, it tries to mimic human intelligence, or it tries to mimic human capabilities. But it's a big bag where lots of things go, and it's great for selling stuff, right? So if you have AI on your logo, as we do, by the way, it's great.
Okay. Yeah. So AI is much bigger than deep learning and machine learning is still much bigger than deep learning. Deep learning is just a small part of it, which is big nowadays, actually. So it's everywhere because it provided a lot of results, such as ChatGPT, as we already discussed.
You can
Add it.
even complete that with another super buzzword, large language models. So
Yeah.
yeah, which is another subset of
Yes.
deep
So
learning.
large language models would be inside of deep learning, even.
Yeah.
Yes. So these are just subsets of things. And talking about large language models, what are the main research trends in deep learning nowadays? Large language models is one of them, right? Um, can you remember any other? Yes, João?
Yeah, so there are a lot of research going on in different directions. We are at a stage that we have reliable products using these large language models. So we want to make them better, more efficient, etc. So we have research all the way like super low level, working at the hardware level, creating different types of hardware that are optimized for this sort of workloads. You have work at the modeling level where you want to learn better how to complete the requests from the users. You have work at an even higher level where you want to make these models behave closer to a human, think the way a human thinks. We tend to think in a structured way, in a making logical connections between things, and these large language models, they don't do logical connections between things. So we are trying to force them into into making them think like a human, so that they can reasonably follow the way we think. And this actually has been showing up positive results. This type of methods is called chain of thought, and they force the models to go step by step, and it actually improves the results of the models. Turns out that we humans know some things.
Yes. Okay. I think, first of all, I would like to ask you to start thinking about questions, because we have a short time for questions, both from Porto and Lisboa. So start thinking about what you would ask to this deep learning, this set of deep learning specialists. And maybe I'll go for one last question, and I would like to hear from each one of you what is the best advice you can give from your experience to someone that is entering, or that is already some lesson that you learned from working with deep learning. And maybe I will start with Guilherme.
So yeah, deep learning is amazing. Yeah, it's amazing. But if you're starting in this area, it can be overwhelmed. The number of methods and research that there is in ML it's really huge. So if you feel overwhelmed, like I did when I start, I recommend you to try to build a strong foundation, like read fundamental books like pattern recognition, deep learning, because if you have a solid fundamental, you can choose whatever the path you want to choose in deep learning, and I think you'll have higher chances of success. Yeah, okay. That's my main takeaway here.
Nice advice. Marta?
I actually agree with this perspective, and based on my own experience, so my background it's not computer science, it's aerospace engineering, so nothing to do with this. So based on my own experience, I think my transition was quite okay, let's say, due to the basics and fundamental classes that we have in the first year of engineering courses. This is not just for aerospace engineering. I believe it's super common for all engineering courses. So it's what Guilherme just mentioned. So if you have a strong foundation, mainly in maths, that's halfway through it. So that's my 2 cents.
Maybe Luis?
I think I agree with what's been said so far. I think we sometimes forget that the research that's popping up every day and all these books have taken years of many people working and thinking about this. So when we get presented with things like ChatGPT or transformers or diffusion models and all that, right? it's just overwhelming. Like there's so many things happening, and I think I've felt many times like, oh, I just can't handle this. This is just too much, right? And I think that's fine. That's fine. Like we shouldn't forget that there's a huge community of people just coming up with ideas, and it's happening in a way that I don't think has ever happened before in any field of science, right? The amount of information, the amount of the different ideas, sometimes the complexity, you know, it's so big and it's so complex that I don't think anybody can call themselves experts in everything in deep learning.
Yeah.
Maybe a few people, maybe 10 people, maybe in the world, but that's it. But that's not Nobel Prize standard, right? So I think it's okay to not understand and to develop your own intuition as you go along. And it just takes many years to get there, I guess, or at least it took me many years to get to a little bit of understanding, right?
Yeah.
Being able to pull off the post-it analogy took me many years.
Yes. Jean.
I would like to go in a different direction. I would go with how important it is to correctly evaluate the models.
Okay.
It is extremely difficult to evaluate whether a model is working properly for the task at hand or not, especially if the task is not to answer a closed form question. If it is, for instance, text generation is very open-ended. How do you evaluate the quality of the models? How, more especially, how you do it quickly and scalably? It's very hard to do it scalably. You can do it by hand. Of course, you ask the model to generate 10 examples, you look, oh, it's good or it's bad, but that's not evaluation. And as you are iterating on your product, you will need very quick ways of evaluating whether your model is going in the direction you want or whether your product is actually regressing, going in the wrong direction. So I would go with the importance of establishing a very high quality evaluation pipeline from the beginning so you can iterate on your product. It's very hard to control the training of these models, and if you don't have a proper evaluation pipeline in place inside your product, you don't know whether you are improving or not.
Perfect. A bunch of very nice advices. If I can add one, if you like deep learning and if you want to learn about deep learning, join our community because we're all about that. And actually surrounding yourself of people that are interested in the topic, I think it's one of the best ways to learn about the topic. And probably you know that because you are in a community of that likes startups and entrepreneurship, so you might know. So maybe it's time to get some questions from the audience. I would like to see some hands up. If you have one, no?
We have.
Okay.
We have one here in Porto.
Oh, okay. We have one here first. Let's go here in Lisbon.
Hello. I'm curious about what is the thinking process to include machine learning in the classical software engineering projects? Is there some recommendation or best practices?
Yeah.
And to add, I saw lots of enforcement of machine learning usually comes from tech people rather than from the product development team. So,
Okay, how do we include machine learning in the point of view of software development? Maybe someone that is developing. Well, I think all of you are actually developing things using deep learning. So, who wants to start?
I can try to answer that.
Go.
So at the end of the day, these models are still software. So you write code and all that for these models. Contrarily to most types of software, it can fail in unexpected ways. So when you have software, for instance, a website, and you click some buttons, it can fail, and it obviously fail. You can see the failure like immediately. With models, it might fail in subtle ways. There are a whole research direction, which is adversarial attacks, which exploits failure modes of these models. For instance, today, there was a research team that found out that you ask ChatGPT to write the word poem over and over again. At some point, it starts regurgitating the training data. And this just came out today. So it's a major flaw in your model. So you have to be creative in, again, how you evaluate the model when you put it in production.
I think I can add something. So following this recommendation, I also believe it's super important for you to define a baseline model. So something that it's not machine learning, it's not AI, and it's the thing that you want to beat. So this is the threshold. If you have a model that is better than this baseline, it means that it's okay and probably it's feasible to put this model into production. But if you have a model just because and you have non-machine learning tools that perform better, don't use machine learning.
Do you want to add something, Guilherme or Luis?
No, I think João said it all.
Okay.
I really like his response.
Yeah.
Yeah, I'd just like to point out one thing that's so I like to think about all this in a spectrum, right? So on one hand of the spectrum, you have things you can code yourself because you know the rules, right? So and they're explicit, so you can just code them, and that's great. And as João said, we're building software. So in that spectrum of software, you have one end where I know the rules, let me code the rules. That's great. If you're in that world, that's great. And then there's the other end of the spectrum where you don't know the rules. So when you don't know the rules, there's methods, namely some called machine learning, that allow you to try to write that software by observing examples so that the rules are learned by examples. So there's a spectrum, right? So it depends on what we're building. And are you building something for which you know the rules? Then just code them. Right? But if you don't, or those rules change with time in ways that you don't understand, then you're in the other end of the spectrum. So you need to use machine learning to build your piece of software.
Yeah.
So I really like to put it this way. We're writing software. We have different ways, different strategies to write software. And it depends on where in this spectrum you are. So you just use machine learning when it's easier to look at the examples to build the rules versus you writing the rules yourself.
Yeah. It was a great question. It's actually machine learning development is kind of, at least in the startup level, it's kind of new. So yeah, the methodologies are still evolving. We can discuss that in the networking. So we have the topic for networking, and I will ask the question from Porto.
My name is Sina. Thank you very much. My question is that what's your estimation about having AGI? How many years?
A great question.
Who wants to start?
If you know, let me know.
That's a nice answer. Yeah. Does someone want? It's a very hard question.
Yes,
it's about
a difficult question.
Yeah.
But I think we've not yet started in AGI. At my point of view, it's still like minimizing a cost function, minimizing your error according to the task at hand. So I think we're not that close as the media say.
Yeah. Any? No? Yeah, there was actually a very interesting discussion on, for example, consciousness last Saturday on the demo day of for the Center for Responsible AI. Thank you. So if AGI means also consciousness, well, I suppose, well, we are not, it doesn't. The answer is it doesn't, but we are far. We are far.
Yeah, but there's a trick actually, because even the definition of AGI,
yes,
it's ambiguous. It's too general. It's super broad. So first we need to agree on this definition, and then let's see.
Yeah.
So can I add one thing to that? This is a nice discussion. I don't want to go too philosophical, so I'm just going to use engineering arguments here. But there's one key thing about AGI or general or intelligence, which is there's one factor that we forget, which is energy, right? And that's a key thing that we always forget, because when we think about the human brain, whatever intelligence we produce, the consumption is 20 watts, okay? So we're very likely the most intelligent being in the universe per watt, per watt, okay? So if your question is, given a budget of energy, will we be able to match or surpass human intelligence? And I say, for sure, because there's going to be a point in which I can inject so much energy that whatever I'm building, it's going to be much more powerful than the human brain. The question is, what is that budget? So it's not so much, are we going to achieve generally, general intelligence, or whatever you want to call AGI? The answer is yes, but at what cost, right? And is that viable? And can we build it on Earth? Do we have enough energy on Earth to do that? So I think those are engineering questions that are much more addressable than the question which is you ask, which is very broad and super undefined.
Nice. We have one more question, I think. Yeah.
Perfect. So my question is a little bit different from that. So it's more on like we had CNNs, now we have LLMs. My question was like, what is the next what is the next breakthrough, or what would you expect to see next? Because yeah, I also agree that we are very far away from AGI, but I'm expecting like something new to disrupt again this space.
Yeah, that's a nice, very interesting question. Do we reach maybe a local maximum? Like, is deep learning hitting a wall now? We can the only thing we can do is put more data into it and make it and apply it to other things, or do you believe that there's some breakthrough going in the next couple of years?
If I might take that one, I believe the evolution of things, it will not be a dramatic breakthrough, it will be over time. And because people are realizing that the quality of the data makes a very big difference in the model that comes out. These very large language models, you have a certain data set and you are not even training in the entire data set. You don't have a compute budget to go over the entire data set. You select a subset of the data set. And people are finding out that if you curate your data set and create a higher quality data set and actually go several times over that data set, it produces a better model. So I still think using the current architectures, you can squeeze the more performance if you just curate your data better. And also you can see transformers, or you can see CNNs as a generalization, or you can see transformers as a generalization of CNN. So transformers is already very versatile.
Does someone wants to add something?
I have one more question here at Porto.
Okay, so let's go to that question. Yeah.
Okay, so if we think about foundation models, the cost of prediction, let's say, has been dropping by a lot. In a sense that if I take the projects that I had to do 5 years ago, it involved a lot of development, a lot of training machine learning models. Now it's just comparing embeddings and even asking ChatGPT what it thinks about these images or whatever. So I feel like, yes, us as data scientists, etc., we need to learn the fundamental parts of deep learning and all of these technologies. But for the average user, I believe the focus has drifted from deep learning, prediction, etc., to decision making, right? So how I can make relevant quantitative decisions for my business, so I transform these predictions into decisions. And now the focus, I believe, should be more on that line than on the training data component part for the majority of people, not for practitioners of deep learning, but for the majority of people. My question is, think about what you need to learn now, not from a deep learning practitioner, but as a general individual out there that wants to use deep learning for real applications, especially how you train people in decision making when people is so irrational by in nature, right? So that's my question.
Okay, so how to take decisions from deep learning predictions in a sense, because it's not the same way you would use any other kind of software. Does someone want to add something?
I can answer.
Yeah.
Sorry.
Okay. So
Yeah.
let's go
Guilherme,
with
yeah.
Guilherme first. Then you add.
Okay. So in our company, we actually have a use case that follows your criterion. That is, I think I've said it here. That's real-time posture correction. So we don't have a lot of data. So we don't have a deep learning model where we could train on a big data set. So we have to rely on another approaches, such as statistical approaches, that given a combination of retrieved information, you have to decide if this is the ideal posture correction, because you want to minimize injuries in real time. So I think decision-making, that this is the way that you're referring to, right? Decision-making after having the predictions from the model, what is the decisions that you do with it? Yeah, I think it depends on the case. Like if ChatGPT fails predicting the next token, I think it's not that severe as in healthcare, as we do, because if we said that this is the good posture and it isn't, it can have like real injuries in the life of our users. So yeah, I agree with you. This is a good approach to see things in common application, common real life applications.
Mm-hmm.
Yeah, that's a good question.
Yeah, that's my main question. Like, what type of skills should we teach to kids nowadays, since they will be making autonomous decisions based on this prediction?
You have to be conscious on your decisions. You have to be responsible. That the model just gives a probability, a decision that is a probabilistic decision, and it's our job.
Oh.
Hello. So the model just gives a probabilistic decision, and it's like our responsibility and our job to make the best decision rules after that. So, yeah. I feel I didn't answer your question.
maybe.
I really feel that this is a relative approach. So it really depends on how you see your problem.
Maybe Marta can also help answering.
Yeah.
So Marta, who has also a very an interesting application, right?
Yeah.
With neurospace.
Space.
Yeah, space.
As the name says.
Yes.
Yeah.
So how does one make decisions based on?
I do agree that, first of all, you need to look at this as a tool. I'm thinking about ChatGPT, because you mentioned foundation model, so I'm thinking about this. You need to be critical as everything else in your life. So it's a tool, and you need to be careful, and you need to understand that it fails a lot, by the way. So the same way as you search on Google, or even when you read a book, you need to be critical. So I think we just need to emphasize even more to kids and teenagers that be critical. Don't believe everything you read, and look at this as a tool. So in school they teach me how to use Excel, and I'm terrible at it. So it doesn't mean that. Yeah, it's true. Python all the way. So it doesn't. If you teach something, it doesn't mean that it will work. But it's good to emphasize that you need to be as critical as everything else in your life. Don't take it for granted. And if your application, for example, my application is space debris. So meaning that we use AI to understand if collisions between satellites and space debris will happen. So imagine if indeed collisions happen. This is super critical. So whenever you use these models, if your application is high risk, high stakes, just be even more critical.
Yeah.
And that's it, I believe.
Yeah. It makes a lot of sense to kind of, and answering to what kind of skills would someone teach to children. Well, understand when they are sure about something and what kind of confidence you have and what kind of care you should take in each situation. I think it's a very great skill to teach skills nowadays.
If I may add, I would include getting into the habit of trying to break the tool. It gives you a very good idea of when the tool works or it doesn't work. So if you get into the habit of getting your hands into these models and try to break it, try to find the cases where it fails, then you start having a good sense or when to trust the model or when to doubt and second guess the quality of the model.
Perfect. Yes. We should close, right? And go to a good session of networking.
Question here in Port. Sorry, Luis.
Yes.
We have one more question, can we?
Patricia, should we? The final one. Patricia says the final one. You can go.
Hi, David Carvalho from Infinite Foundry. So I have a question about how deep these networks have to be, because obviously they have to be big if you have to do very complex tasks. But the question is, how big? Do we have metrics for this? Because obviously there are a lot of works that have bigger and bigger models, but then you see, oh, a 7 billion parameter model actually outperforms a 12 billion model, right? And this is a very costly choice, because if you have a very big one, it's very expensive to train. So do we have metrics for this? Not just the simple, oh, we have an error function, we minimize this, it works fine. Do we have ways to more intelligently understand how big, how deep a model should be to understand a certain task?
Okay. Who wants to start?
I can
go.
Do. Yeah, we have research on that area. It's scaling power laws. I don't know if you heard it, but it's basically a paper that tries to estimate what should be the size of the model, assuming a certain amount of data and given a budget. So it's a function of these three parameters. I think that's what you're referring to, right? So if you have a budget that normally companies do, and you have pre-established data, then you can calculate what's the best side of the model to achieve the better performance. Yeah.
Nice. And I think we are. I think we are done. We're gonna close, and you can still talk in the networking session and answer all the questions. So yeah, Patricia, please.
Okay, so thank you, Luis, and our panel speakers. Please, a round of applause for them for this brilliant conversation. So I want to thank you all for being here and the startups that we're pitching here. We'll have time for networking now, either in Porto or here in Lisbon. So I'll ask you to take the conversation upstairs or to some drinks. I also want to remind you that next week we'll start a program called Sim Circuit. So we'll be showcasing startups throughout all the country. So keep an eye on the events near your city, either if you're in Lisbon or in Porto or in other cities in Portugal, to know about what will happen in your city, and we will present the vouchers for startups and the vouchers for incubators and accelerators, and also give you some tips for applications and connect you with some investors in the area. So please stay tuned to this information, and we hope you can participate in an event near you. So that's all. Thank you, and have a nice day.